Going on now to the last PowerPoint series of slides for Section 8 of Chapter 5. Here we're talking about applications of polynomial equations. And once again, I remind you, we have a lot of examples worked out in the additional exercises series that are below this on YouTube. But this is sort of an introduction to it to give you an idea what it's all about. One of the things we mentioned before is fitting polynomial functions to data, often referred to as regression. All right, well, let's get started. Suppose a fireworks is launched with an upward velocity of about 80 feet per second from a height of 224 feet. Its height in feet, and t is of course time, after t seconds is given by this equation. And this is a quadratic equation. After peaking, how long will it be before the shell is 224 feet above ground again? Now, a good thing is reread this, but here is the formula we need. We're looking for time here. Once we put, and again, the 224 is in there. So we can make a drawing. Okay, that's going to be useful. And notice time cannot be negative. So we're up on a hill or somewhere and we're shooting off this rocket and it's going to go down. And then eventually it's going to reach the ground. And here it looks like it's going to reach the ground in 7 seconds. But we're wondering when it will be about 224 feet above the ground again. So if we take our line tool and where is this? We're just going to make a straight line here. Can you see it's going to be right about there? And what time is that? Well, 5 seconds. But again, I don't think it's going to be this easy. They want us to do some algebra here. So, solving it by algebra, we're going to say that this height over here, again, we want it to be 224 feet. So there's our basic equation. We're going to subtract this from both sides. We put it in standard form. And we factor out a common negative 16t out of each term. And we get this, that equals 0. And this, that equals 0. Remember, we're using the 0 principle of factoring, where a, b equals 0, and we equate each of the factors to 0. That's what we've done here. So here it's going to be 0, which we kind of throw out. That's where we started, actually. That was our y-intercept. And then we set here at 5 seconds. So our diagram matched out pretty well. And that's what we said when we checked it. And that one works. Okay, we're now going to take a look at the Pythagorean Theorem. And we may have mentioned this before too, that if you have a right triangle, a triangle in which there's a right angle, then the legs are the sides adjacent to this right triangle, and the side opposite is the hypotenuse. And we say that if we square A, add it to the square of B, that would equal the square of C. And there is the Pythagorean Theorem. But then we want, or they want us to do some work with it. So here we have a ladder, and you're going to have something like this. So let's set this up here. I could just use the slides, but I like to work it too. So we're going to have a house, side of a house here. And we're going to have a 13-foot ladder leaning against that house there. And then we have the ground, of course. And there's our right triangle. So these are legs. And we know the length of the hypotenuse. The length of the hypotenuse is 13 feet. Now the distance from the bottom of the ladder to the house is 7 feet. So this is going to be 7 feet. Oh, wait a minute. The bottom of the ladder to the house is 7 feet less than the distance to the top of the ladder. Oh, okay. So this is going to be x. We don't know this. And this is going to be x minus 7. Yeah, you probably should read the whole example before you start, but I would modify it like I did. So the distance from the bottom of the ladder to the house is 7 feet less than the distance to the top of the ladder. So this is the distance. So this is going to be x minus 7. How far is the bottom of the ladder from the house? So we have to solve for x and then subtract 7 from the x, and that'll give us this distance. So what do we have here then? Well, we have a squared plus b squared equals c squared. This didn't come out very well here. There we go. So what is a squared? Well, it's going to be x minus 7, the quantity squared, plus x squared, that's b over there, equals 13 squared. So let's just do this. So we're going to use that special technique of squaring a binomial. Square the first term, multiply these, double it, and square the last term. Plus x squared. Now 13 squared is 169. So you might say, well, what is our next step? Well, we are supposed to put it in standard form. So we have this one and this one. This is going to give us 2x squared. This is still minus 14x. And now we have to subtract here. Okay, so we're going to subtract now the 169 from a positive 49. That gives us a negative 120. And then I see a 2 there, a 2 in there, and a 2 in there. So I'm going to factor out a 2, make my numbers smaller. And then now I have to factor this. So this is going to be an x and an x. And I want factors of 60 that have a difference of 7. And what I did is I did some of my mental gymnastics over here. And I got a 5 and a 12. And that's a difference of 7. So this is going to be a negative, and this will be a positive. So here, x is going to equal a negative 5, and here x is going to equal 12. So we now know our side here is 12. And what is 12 minus 7? Well, this is 5. So how many feet is this from the wall? 5 feet. Okay? And we use the Pythagorean Theorem. Read the problem carefully. Had to do it more than once, which is very typical of me anyway, and made a picture and then applied it to the formula, and we did the factoring as is indicated. Now we'll see them do it. And again, they have a little figure similar to ours here. And there's our one side, there's our short side, and there's the hypotenuse. And we expanded this binomial and got this. Remember, this is a perfect square trinomial. You see this little 2 here? That's an error. There's no 2 there anymore because we already expanded it. Yes, they didn't put it there. Then we grouped like terms. Then we subtracted 169 from both sides and got this. They divided by 2. Very good. I would do that. Then they factored it. And when they factor it, they get a positive 12 from this and a negative 5. Well, you can't have a distance that's negative 5, so this is rejected. And we check it, and it all checks out. And there's our answer statement. The ladder is 5 feet from the house. And this is one of those standard right triangles, which is 2, 12, 13. Now, I don't believe you're going to have any this difficult, and it is meant to be solved by using a calculator where you program the calculator to do this. But let's just look at the data. There's the year. There's the in-state public college tuition. Now, when I graduated from college, Southern, the tuition was $100 a year, well, a semester. When I started, it was only $10 a semester. So public tuition has gone up, and of course you know what tuition is like around here. Do you see sort of a straight line there? Let me get my line tool going here. And if I put a dot there, and if I go like so, see, that's sort of a straight line. And it's not quite a linear, but it's close. So what they're wondering about, if you were to extend this, remember that would be extrapolate. And you could actually do that using your calculator. And again, we're not going to do that. The numbers get to be quite tedious. So that predicting public tuition, it would be about this in 2006. But again, I don't believe that they're going to have you do any of this difficult at this stage. Okay, that'll wrap this up, and good luck with your Chapter 5 test.